Hi guys, today we're going to do the second part of exercise 3.3 from your Jacplus textbook. So it's still quadratics over R. So the other worked examples, the previous ones, are in another video, so you might want to check that out before you do these. So look, example 7 is asking us to use the discriminant to determine the number and type of roots to this equation here. So what the discriminant is, we use a little triangle to represent it. It's the discriminant and it's b squared minus 4ac. And you might remember in the previous video when we did the quadratic formula, it was negative b plus or minus root b squared minus 4ac over 2a. So the discriminant is, the discriminant is the thing that goes in the square root like that. So it makes sense then that if that is positive, so if we have the square root of a positive number, well, that can equal plus or minus 5. So that means we have two solutions. If we have a negative, well, you can't root a negative, so there's no solutions. And if you had a perfect square, well, actually like a, 0, well then the square root of 0 equals 0, so then there's just one solution. So there are three scenarios, and of course it doesn't have to be 25, it could be 10 or 15 or 100, whatever it is. The point is, if the discriminant is positive, you have two solutions, negative, no solutions, and 0, one solution. And that comes in quite a bit. So in this case, we've got, there's our discriminant formula, and I'm just going to write the equation again. And I'm going to put ax squared plus bx plus c equals 0. And what this then shows us is that a equals 15, b equals 8, and c equals neg 5. So I'm just going to write them here so we can easily see. And then I can put that in to discriminant equals b squared minus 4 times a times c. So let's see, that gives us 8 squared is 64. And then this is important, take note of the negatives and number of negatives there. So there's 2, so it's going to be a positive answer here for this part. 15 times 4 is 60. 60 times 5 is 6 5s are 30, so 300. So our discriminant equals 364. So what we can see about this is that it's a positive number, so two solutions, but they're also asking us for the type of roots. So roots is solutions as well. So the number of roots, and I'll change it to roots just so we're doing what's exactly in the question. So 2 roots, but this is not a perfect square. So it means that, well, if you were to square root this, you're not going to get 10 or 5 or 18 or something. It's not a perfect square. So that means that our solutions will be irrational. So irrational roots. So 2 roots and irrational, they're irrational. So that would be how we do that. Let's move to the next one. So it's still example 7, part B. So looking at the discriminant again. And this time they're giving us k in there. And this is quite important to be able to do this, but people don't do it very well. So you want to practice more of these type of questions. So you want to find the value of k so that we have one solution or one real solution. So in other words, when you see the word one solution or two solutions or no solution, that's a bit of a light bulb moment where you've got to think, well, that means it is talking about discriminant. And in this case, the discriminant, or delta, equals 0, because for one solution we need the discriminant to equal 0. So let's write it out, x squared plus kx minus k plus 8. And this means, well, we've got ax squared plus bx plus c. And the a is easy to see, or easy-ish to see. There's the secret 1 there. So a is 1, b is k, but c, well, c is all this. So this whole leftover bit is c. So what's in front of the x is b, what's in front of the x squared is a, and then what's left over, that's c. So let's just write them out. B equals k and c equals neg k plus 8. And then, well, now we can just find the discriminant. So discriminant equals b squared minus 4ac, that thing that goes in the square root of the quadratic formula. So we've got b squared minus 4 times a times c. So let's put that out, x squared, and then, well, negative 4 times 1 is negative 4, neg k plus 8. So I'm going to have to expand that. And be careful, it's negative 4 times negative k, so it's going to be positive 4k, and then negative 4 times positive 8 is negative 32. So I've got the discriminant there, so far so good. We've found the discriminant. We've got to find the values of k so that the discriminant equals 0. So for one solution means discriminant equals 0, and we've found the discriminant now. So what was it? K squared plus 4k minus 32. And, well, we've got to equate that to 0. So now it's a matter of actually solving that to find out what values of k will equal 0. And this in itself is a quadratic. So I mean, this is the discriminant, and if we were going to graph it, well, it would be the discriminant on the y-axis and k on the x-axis. And I'm going to graph this quadratic here. We haven't graphed yet, and if you've forgotten it from year 10, just, you know, don't worry too much about this part yet, but I'll still show it. So k times k is k squared. We're doing cross multiplication here. And then let's think positive 8 times negative 4 will do, because we want a positive value in the middle. So let's cross multiply. K times negative 4 is negative 4k. K times positive 8 is plus 8k. So negative 4 plus 8 is 4k. And that does equal the middle term. There it is. So that means that in our brackets we'll go k plus 8 and k minus 4 equals 0. And if you do remember from last year, in year 10, where you sketch quadratics, we can find the x-intercepts like this. I might do that after. First I'll just say k plus 8 equals 0 and k minus 4 equals 0. So we can see that k equals negative 8 and k equals 4. So these two values are the values of k that will give us one solution, because that's what happens when the discriminant is 0. For those of you who want to sort of look a little further, well, if we were to graph this, that would be an x-intercept at 8 and an x-intercept at negative 4. So your graph would look like this, and we're talking about where the discriminant is going to be 0. So we're talking about those values here. So on the graph, this is discriminant equals 0 in yellow. If we were looking for when the discriminant is greater than 0, that's these parts here. So that would be for two solutions. Two solutions. This is one solution where it equals 0, and then of course the last bit, well, when the discriminant is negative or less than 0, it's here. So discriminant is less than 0, and that's no solutions. So this you don't have to know yet. Don't worry too much about this yet, but it comes later. It's quite important. So look, in any case, let's move forward. They also ask us to check that this is going to give us, I'm just going to double check the wording there. So we found the value of k, for which the equation has one real solution, yes, and check the answer. Okay, well, let's check the answer. So this is our equation here, x squared plus kx minus k plus 8 equals 0. Let's see, x squared, I've forgotten it, x squared plus kx minus k plus 8, I think. Yep, plus 8 equals 0. Well, let's sub in those values. So now we're doing the check. So I'm going to sub in neg 8. Negative 8 squared plus negative 8x minus negative 8 plus 8 equals 0, and that will be 64 minus 8x plus 16 equals 0. And well, if we check for how many solutions, because remember we've got to check that we have one solution, well, that's going to be, we get, oh, I've accidentally subbed that into x there, ignore that, x squared. So now we can say x times x is x squared, and for 16, negative 4 times negative 4. So x times negative 4, negative 4x. X times negative 4, negative 4x. Yes, that's negative 8x. So that means that x minus 4 equals 0. This is a perfect square. So it means we've got one solution. So x equals 4. Yes, one solution. So let's now try the next one where k equals 4. So when we subbed in a negative 8, we got one solution, which was x equals 4. So now let's sub in 4 for k. So it's x squared plus kx, so plus 4x, minus 4 plus 8. So let's see if we get one solution for this one. So x squared plus 4x minus 4 plus 8 is plus 4. And you can probably see that this is a squared plus 2ab plus b squared. So there is one solution, but I'll still cross-factorise it. 2 times 2, x times 2, 2x, x times 2, 2x. So that equals 4x, yes, middle term. So it means x plus 2 equals 0. And if we solve that, we've only got one solution of x equals negative 2. One solution. So there we go, that's our check there. So quite important to be able to find the value of k. That comes up quite a lot. Let's move to the next one, example 8. Use completing the square to solve the quadratic. Here are the solutions a pair of conjugate surds. So let's say a pair of conjugate surds, well that might be 3 plus root 5 and 3 minus root 5. These are conjugate surds. 4 plus root 7 and 4 minus root 7 are a pair of conjugate surds. So it's like if you can write it 4 plus or minus root 3, when you can do this in there, that's a pair of conjugate surds. So look, I'll rub that out and we'll deal with the conjugate part of it afterwards. Complete the square. Okay, so let's complete the square on this. So it's got a surd in it, which makes it look a little bit yuck, but it's still the same process. So we've got x squared plus 8 root 2x, and we're going to ignore the minus 17 for now and say plus half of 8 root 2 squared. So this is going to make a squared plus 2ab plus b squared, and that is our that will be the square. That's what we're completing the square by adding this part on. So that's x squared plus 8 root 2x. Half of 8 root 2 is 4 root 2 squared. So x squared plus 8 root 2x plus 4 squared is 16 times root 2 squared is 2. So x squared plus 8 root 2x plus 16 times 2 is 32. So now we've got a minus what we've added on. So when we did this, we added on 32. So here is our complete square, and minus 32, and then I'm going to put this negative 17 back on. All right, so let's see. Now I'm going to get, this is a squared plus 2ab plus b squared. So let's factorize that to a plus b squared, which is a is x, b root 32 squared, minus 32 minus 17 is minus 49. And I reckon we can simplify that root 32. We certainly can. So let's see, 16 times 2 is 32. Let's move this down. So that means we've got x plus, this is 4, and this is root 2. So those two come to 4 root 2 squared minus 49. And while we've completed the square, we've got to equate it to 0. And we want to see if the solution is a pair of conjugate surds. So if it's a pair of conjugate surds, you're going to have something plus or minus in the middle. So look, let's solve it. This is a squared minus b squared equals 0. So a minus b, a plus b equals 0. So let's see, I'm going to say a equals x plus 4 root 2 and b equals 7. So a is the square root of this and b is the square root of this. And that means I get a minus b and a plus b equals 0. Oops, not b, 7. So now let's solve each of those. So x plus 4 root 2 minus 7 equals 0. Let's solve. So x plus 4 root 2, I'm going to add 7 on both sides. X, I'm going to minus 4 root 2. So that's my first solution. Let's check the second one. So here we've got x plus 4 root 2 plus 7 equals 0. So let's solve that. X plus 4 root 2 equals negative 7. It's minus 4 root 2 on both sides. So let's see, they look very similar, but are they conjugate surds? Let's see, do we have plus or minus the surd? No, we do not. Not plus and minus, so not conjugate surds. If it was, it could have been 7 minus 4 root 2 and 7 plus 4 root 2. They would have been conjugate. It could have been negative 7 minus 4 root 2 and negative 7 plus 4 root 2. That would have been conjugate. But the ones we have got, we have plus and minus 7. The surds, however, are both negative 4 root 2. So it's not conjugate surds. All right. That is that. Anything else we had to do there? Other solutions of pair of... No, we've done that. I think we got 2 more. Okay, one root of the quadratic equation with rational coefficients, blah, blah, is x equals 6 plus root 3. State the other root and calculate the value of b and c. Okay, so it's got rational coefficients, fine. So we're trying to find b and c. And we can see that one solution of x is 6 plus root 3. So that would mean that our other solution is going to be 6 minus root 3 because they will be a pair of conjugate surds then. And that would give us, that would lead to us getting a rational, like the rational coefficients. So in that case, if I want to write this equation out, I can say x equals 6 plus root 3. So then if I minus 6 on both sides and minus root 3 on both sides, x minus 6 minus root 3, that's the first one. And the second one, x equals 6 minus root 3. So now I'm going to minus 6 on both sides. So x minus 6 equals neg root 3. And I'm going to add root 3 on both sides. So it's x minus 6 plus root 3. So in other words, if I expand these brackets here, if I'm able to note that they are a minus b, a plus b, I'm going to be able to get my equation in this form, and then I'm going to be able to see what b and c are. So state the other root. So our other root was this. And I should really call it, I should actually say x equals 6 minus root 3, so that would be my answer for the pink part. The second bit, calculate the values of b and c. So let's do that now. So, running out of room a little bit, I'll move this away. So let's have a look. Here, actually, this and this are the same. So what I can say, I might not do that in pink just so people don't think that that's the solution to the pink part. So what I'm going to say here, this is A minus B, A plus B. So if that's A minus B, A plus B, then I can say, well, it's going to be, if I want to expand that, it's going to be A squared minus B squared. And A squared minus B squared, so x minus 6 squared minus B, which is root 3 squared. So let's expand. That gives me, you can FOIL this if you want, but I'm just going to use the identity. A minus B squared is A squared minus 2AB plus B squared. So that's going to give me x squared minus 12x plus 36 minus root 3 squared is 3, not 9, 3, because it's root 3 times root 3. That equals root 9, which equals 3. So be careful, that's a common, not even misunderstanding, just weird mistake. So x squared minus 12x plus 33. So now I know that this is x squared plus bx plus c. And you know, now it's really quite nice because we can see that b is neg 12 and c is 33. And that is our answer. So, last one, and I'm going to have to move it away because I am absolutely running out of room. So, this is a little bit hard, but if you can identify that it is a substitution with Z, or A or P or whatever you want for your letter, then you're going to be okay. I'm going to make it equal 0, 3 plus 2 root x minus x equals 0. So I've just taken x over onto the left-hand side. And then I'm going to say let z equal root x. And you know, that means 3 plus 2z minus z squared equals 0. So here I've now got a quadratic. Negative z squared plus 2z minus plus 3 equals 0. Let's divide by negative 1 on everything, because then we can have a positive for our z squared. 0 divided by negative 1 is still 0. And then I can solve z times z, and neg 3 times 1. And I get z times 1 is 1z. Z times neg 3 is negative 3z. And of course that equals negative 2z, which is what we want. So this and this are going into brackets. Let's do that. Z minus 3, Z plus 1 equals 0. And now, I mean, we can be careful because people will go Z minus 3 equals 0 and they'll say Z equals 3, which is true, but it's not the answer because we've got to do in terms of x. So we've got Z equals 3 and Z equals negative 1. So let's have a look what it was. We said Z equals root x. So root x equals 3, square both sides, x equals 9. And root x equals neg 1, square both sides, x equals 1. So you might think you've finished now, and often you will be, like often that will be the end of it, but you do have to check because you may not be. So I'm highlighting both of these, but one of them may not work. And let's have a look back at our equation. So it was 3 plus 2 root x minus x. 3 plus 2 root x minus x equals 0. So let's make sure they work. So let's sub in the 9 for a start. 3 plus 2 root 9 minus 9 equals 0. Let's see if it does equal 0. 3 plus 2 root 9 is 3. So 3 plus 6 minus 9 equals 0. That's true. So this one is a solution. So I will keep that there. Let's change the 9 to a 1. So now we've got 3 plus 2 times 1 minus 1. So that's 3 plus 2 minus 1 equals 0. Well, that's not so true. 3 plus 2 is 5. 5 minus 1 is 4. So that's not true. So this one we reject. So this won't work. So in this case, I think if you notice that you are using a Z substitution or whatever pronumeral you like, just don't use X and Y because they are used in other ways. I like Z. You can choose something else, plenty of letters in the alphabet. So when you substitute, you get a quadratic, and you can solve the quadratic really quite nicely with cross-factorization usually. So then the other hard part is just making sure that you remember to substitute X back in. It's not Z. And then, checking the validity of your results. So that completes all the examples from 3.3.